This is Killer Innovations, a show about ideas, creativity, and how you can innovate. Welcome to the Innovator's Garage, where you learn to create your next game-changing killer innovation.
Welcome back to the show this week. We are actually live back in the studio. I've been on the road a fair amount here lately, and though it is good back to be back in the studio versus trying to do record the show while I'm out and traveling. We will be actually live here for the next couple of shows. We've got some really great, exciting guests. We're also thinking about an upcoming show where it's kind of an Ask Phil format. You've been great participants in that, queuing up questions that you've been wanting to ask, but we haven't had really an Ask Phil show probably in a couple of months. So this would give you a shot to ask whatever questions you might have on anything we've covered in the show, innovation, creativity, advice. We've even had people pitch their ideas for funding. So we're kind of open to all formats, all opportunities. So other updates that are coming up, we have launched the Innovators Community, so you can check that out. Just go over to theinnovators.community. It's an online community for innovators, creatives from around the world. We have leading innovators from like chief innovation officers at major companies, all the way down to startup people who are just working on the base idea, or maybe some highly creative individuals trying to figure out how to change their company or their organization. So check that out. It's over at theinnovators.community, and look at becoming part of that. It's the best place today where I'm hanging out and spending most of my time these days, interacting directly with creatives and innovators. Okay, let's get into today's show. We do have a guest today. This is a guest that actually got onto our radar screen on some articles that were written about the research and the projects that they have been doing around new kinds of interaction techniques. There's been this interaction techniques of touch surfaces, touch skin, those kinds of things, as far as those kinds of techniques. And our guest has been involved in all of that over an unbelievably extended period of time. So I'm going to go ahead and bring Chris in. So Chris, how are you doing this morning? Appreciate you taking the time out of your busy day on Sunday to come join us.
Yeah, I'm great. Thanks for having me.
So Chris is the assistant professor. Okay, I'm going to read this title because if I try not to read it, I'm going to screw it up. Human-computer interaction at Carnegie Mellon University. So what is human-computer interaction? Define that term first for our listeners.
Yeah, well, it's a term that means different things to different people. But broadly, it's people with an interest in technology, whether that be from a computer science standpoint or a design standpoint, or even like a social psychology, behavioral science standpoint, that want to make computing technologies able to enrich human lives. So that ultimately computers are a tool, and we want to design that tool as best possible, taking into account the very weird and often delightful aspects of humanity, and to make technology as good as it can be.
Okay, so how do you get into this kind of background? Have you always been into computer science? Is that kind of what you got? You knew what you're going to do as a kid?
Well, I don't know if it was what I wanted to do as a kid, but certainly I've always enjoyed computers. It wasn't really until undergrad that I decided to major in computer science and went on to get a master's and PhD in computer science. But what I always wanted to do was not just sit there and sort of program all day long, but really be involved in the creation of new interactive technologies in particular. So not just about making, operating systems crash less or databases more robust or all those, super important topics that computer science has made tremendous strides over in the past, 5 decades. But really think about the new ways that we could see and explore technology, how to get interesting technologies onto people's bodies and into people's hands to really change their conception of technology. And for that, we have human-computer interaction.
Yeah, I mean, it's, some people may confuse this. Some people refer or use the term human interface. Is it the same, different, part of it, not part of it?
Yeah, human interface is definitely part of it, but more importantly, it's that interface between the human and the computer. So designing a good human interface is very much what human-computer interaction researchers study, but we also have to understand the human, and then even beyond the interface, what are the implications behind that? Like Skype is an interface, but the implications of video chat are much larger than what that interface is. So we try to think about technology, computing technologies, holistically, and understand all of their design implications and the technical implications as well. And
so you did your PhD at Carnegie Mellon and then joined the faculty. Where did you do your master's at?
I did both my bachelor's and master's at New York University at the Quran Institute.
Okay. And what was your master's thesis on? I'm always interested because it sometimes never doesn't have a direct correlation. I have a feeling though that you do have a direct correlation, but I'd be interested.
Yeah,
what was your master's?
Not a thread of research that I continued, but I had a great thesis advisor who let me sort of run wild with my imagination. And my thesis topic was designing a new conception of file systems. You know, right now the file system on your computer is hierarchical. You have folders and folders and folders and folders, and you have little files in them, right? We said, well, that's a hierarchical sort of categorical way to organize files. What about if we think about files in time? So when you're working on producing, let's say, a radio show, you might have the logo being edited at the same time as the script, which is being edited at the same time as some, kind of intro graphics, right? Or video or sounds or whatever. So we saw that modern day computing tasks tend to have different types of media. And the thing that brings them together is the temporal context. So that's something that could have been exploited. So organizing your time system by time, instead of having to manually organize everything into folders, felt like something that was interesting to explore. And so we built this prototype file system that was based entirely on time and keyword. So it's more like a relational database with a timeline than any folders.
So in this case, was there any surprises? You thought it was going to have one use or benefit, but you uncovered something that was unexpected as part of your research?
Yeah, I mean, it's a good question. It's not something I've thought about, honestly, in like a decade. But I think the most interesting thing were those patterns of activity. Mm-hmm. That we tend to organize things inherently by time, by stuffing them into sort of folders of related content. But actually time can do a lot of that heavy lifting for us because we automatically tend to edit things together. Now, some might argue now that because we're doing so much multitasking on computers, that actually it's we don't do things in blocks of time so much anymore. But certainly when I was doing this research, we saw when we analyzed people's edits of files, they tended to be clustered together. And I think that was the most interesting finding, and it actually led to another project that I did between my master's and PhD at AT&T Labs, working on a timeline-based view of social television.
Yeah, that's an interesting one, because you and I were talking before we kicked off the show, given that I am now heavily engaged in the media industry in my CEO role, and you were doing some of this research at AT&T, and we've been, a number of research organizations have been looking at this kind of concept of social TV, or, it's, social interaction with the sharing of media, I guess, is one way to look at it. So in that case, though, it does have this time constraint. I mean, you really think about it, albeit we talk about multitasking. There's been a recent study that came out that said we really don't effectively multitask, and in fact, it actually is harmful to productivity. And so therefore, the time thing becomes even more interesting, I think.
Mm-hmm. And you can detect those patterns of activity, so you know whether people are getting highly interrupted, or they had a 2-hour block of time where they could really crank out some work. So now with advances in things like machine learning and AI, we can actually automatically extract those patterns of activity while you're working and make good inferences about your state of mind, and can help better support people producing work on computational interfaces.
So did the work on your looking at kind of this time orientation for the work we do, does that have a play into your work on the computer interaction, presenting certain interfaces because it knows what you're doing and therefore doesn't clutter it all up with the 500 options you have in Word, just presents the ones you're most likely going to use because it knows kind of the pattern that you're doing?
Yeah, I mean, this is a huge field of work, but I've certainly done work in what people would describe as context-sensitive computing or context-aware computing, where today's computers, whether you have a smartphone or a laptop, they really know nothing about what you're doing. My phone, if I didn't put it on silent, would happily interrupt this, broadcast. Even though it should know by the tone of my voice and the fact my laptop is configured in a different way, it should not interrupt me that this is something important.
Yeah, and I would love to have that feature because I can't tell you how many times either guests or me, people knowing they're live on the show, go ahead and send me a message. Even fans have sent me text messages in the middle of the show and caused the phone to beep. So we're going to take a quick commercial break. When we come back, we're going to pick up our conversation with Chris Harrison, talking about his work at Carnegie Mellon. And in particular, we're going to take a look at a research project that he has called Electric, that I watched the video. This thing's amazing. You're going to want to check it out. So don't go anywhere. We're going to be right back after this quick commercial break.
Biz Talk Radio. This is Killer Innovations, a show about ideas, creativity, and how you can innovate. Welcome to the Innovator's Garage, where you learn to create your next game-changing killer innovation.
Welcome back to Killer Innovations. I'm your host, Phil McKinney. Before we hop back into this segment, I need to do a quick shout-out to one of our sponsors, and that is Zoom. Zoom has been a long-time supporter of the show, long before they took on sponsorship, giving us access to early versions of the Zoom video collaboration technology, and it's the technology we use to bring the guests in. In addition, I use it every day at my day job as a CEO with my team scattered out all over the world. It is the tool that we use each and every day. Zoom has made available to listeners of Killer Innovations a free account that allows you to collaborate with up to 50 people. So check it out, killerinnovations.com/Zoom. If you're already a Zoom user, don't forget, check it out. Coming up here in September is the Zoom user event called Zoomtopia. So check that out. Eric Ewing, who's the CEO and founder of Zoom, will be there. Great speakers, announcements of some of the new things coming onto Zoom. So check that out. You can get more information of that by going over to zoom.us. But for that free account, hop on over, killerinnovations.com/Zoom. So let's pick up our conversation with Chris. And I apologize, Chris. I just lost. Here we go. There we go. Sorry about that. We had a little technical hiccup there. It's always the case, right? When I'm back live in the show. So, Chris, your work really is in this whole interaction, but if I look at all of your research projects, it kind of falls into this category of next generation touch. Is that a good classification for your work?
That's certainly a major thread in my research lab, for sure.
So walk us through what you mean by that, and then some of the projects that you've been working on. Like I said, I've seen the video on this one called Electric, which I just, spray painting a guitar and putting a touch surface on an uneven surface like that, it definitely opened up my eyes to possibilities. But I'm going to shut up and let you talk about this concept of next generation touch, some of your project work.
Yeah, so touch you can really improve in one of two ways. One is you can make it better, so you can do sort of more and richer interactions in the same small amount of space. So one way this comes into play is with smartphones and smartwatches in particular, where they have small screens. And so what we want to do is make the best use of that small surface area. And there's a lot of projects that me and my students have been looking at that explore sort of the frontiers of multi-touch. What's beyond multi-touch is really poking at, different numbers of fingers of the screen, the best that we can do. And we have many projects that show that's absolutely not true. The second way you can improve touch and touch experiences for people is to provide more space. So to give them more area to do things in. Obviously, a smartwatch is really tiny. So is there a way to give them more surface area in which to do interactions and escape that small screen? And so one of the projects that you mentioned is this Electric, which is very much a trick of electricity. And it allows us, as you just mentioned, to actually just take a spray paint. In this case, it's a special spray paint that's very weakly conductive. It's not like a very expensive material. It's a material actually we just bought on Amazon, but you can spray objects, whether that be a guitar or a toy or whatever it may be, an entire car. This could be done in the factory or even by hobbyists. And then we do some very clever sensing and software that takes advantage of that kind of weakly conductive layer to do a low fidelity touch sensing. So you could take, as you say, a guitar, you spray paint it, you add some electrodes to the outside, and then our software interprets all those signals with a little splash of machine learning in there. And the whole object becomes touch sensitive, very much like a touchscreen you might have on your phone.
So is it a single touch surface? Does it allow for multi-touch surface?
The technology inherently allows for multi-touch, but because it's quite a coarse sensing, it doesn't work particularly well. It's sort of an avenue of future work. So it can do multi-touch. There's nothing that prevents it, but at the resolutions that we're doing, which is sort of plus or minus a couple centimeters, multi-touch doesn't make a lot of sense. You have to keep your fingers, pretty far apart in order to make it so that you can sense the individual fingers. So it's not meant to compete with the sort of technologies you might find on a tablet or a smartphone. Those are really high resolution and very well engineered. This is something you might add to the entire backside of your phone, or even maybe spray, coat the entire interior of a car or the car dashboard to bring interactivity to those otherwise static surfaces.
Yeah, but in your research and some of your writings and in the demonstrations I've seen, one particularly interesting use case for me, though, is in adding interactivity to non-functioning prototypes.
Yes, right. So that's one of the avenues we explored in Electric, where, for example, in 3D printing, it's a really cool technology, and you can 3D print, let's say, a game controller, and what you get out is an object that looks like a game controller, but has none of the interactivity of a game controller. So you get a prototype of the physical form, but not a prototype that encapsulates any interactivity. And so with this technology, not using a spray, but actually just using an off-the-shelf conductive filament, which is just a carbon black ABS. Again, nothing special. We ordered it also on Amazon. These are not specialty materials, no material science here. You can 3D print an object and, again, use our sort of these electrodes that would fit to the bottom of your object, and most importantly, this special software that interprets, I don't want to get too much in the mechanics, but the electric field shunting, to actually detect where touches are happening on a 3D printed object. Yeah, and this lets you, for example, 3D print a game controller where all the buttons actually work, and it's just a block of plastic. There's no wires or anything special inside of that.
That's the thing that was really exciting for me, for myself, but also for the listeners of this show. Part of the challenge is I've got this idea for some piece of functioning hardware, but the cost to get that to turn that into functioning is exorbitant for most entrepreneurs, garage, DIYers to try to translate that, trying to do Raspberry Pi stuff, all that kind of thing. Your approach, though, could allow me to, not even crudely, but with some level of fidelity, simulate the experience of what that finishing device is without all of that lag time and cost associated with it.
Yes, and I think it also opens the opportunity for entirely new interactive goods. We were 3D printing things out of this carbon ABS, but the fact is you could also injection mold it as well. So if you think about how many objects, like the chair that I'm sitting on right now, toys and action figures and whatever it may be, so many things are injection molded. This plastic costs, cents to make an object with, and now it can also be a touchscreen as well. So, instead of having an action figure with wires running through it, so, when you touch the head or something, it triggers some audio effect. Now you can just have a solid piece of plastic with interactivity draped all over its surface for essentially zero cost. And this is what's exciting about it, is we're bringing touch screens and touch functionality to entirely new classes of objects where it's just prohibitively expensive to be able to build, for example, an action figure with a screen on its surface.
Yeah, and that's what makes it really interesting, and it opens up just a huge amount of possibilities for doing. You're designing it for interaction, but I see it, how I would use it is I would build a prototype and then actually test the interaction experience. So we're going to step out, take a quick commercial break. When we come back, we're going to pick up this conversation with Chris Harrison, assistant professor at Carnegie Mellon, on next generation touch technologies. Don't go anywhere. We're going to be right back after this quick commercial break. We're live on Facebook. Submit your questions there. and you're listening on the BizTalk Radio Network.
BizTalk Radio. This is Killer Innovations, a show about ideas, creativity, and how you can innovate. Welcome to the Innovator's Garage, where you learn to create your next game-changing killer innovation.
Welcome back to the show, but before we hop back into this segment, need to give another shout out to one of our sponsors. The sponsor for this segment is HP. Now, all of you have been longtime listeners are rolling your eyes going, hold on, Phil, you're the former CTO at HP. Yes, I retired from HP at the end of 2011. HP has reached out. They've agreed to sponsor. And as you know, the monies I get from any of the sponsorships ultimately ends up in our charities, hackingautism.org or Pioneer Education Africa. If you're interested in those nonprofits, you can go search for them over on Google and check those out. But HP's been doing some great work, most recently around security, cybersecurity, beefing up and improving the security on the devices, including printers and PCs and laptops. So check it out. Given the scary threats that are out there that are coming, all of the threats we have to personal identity, but just your own private information. Check it out. HP's got a bunch of great information. If you want information about the HP technologies that we use here in the studio, hop on over to killerinnovations.com/HP, and there's a write-up there of what we're doing and what they're providing and other things. And if you want more information about HP and the security side, just go over to hp.com. Right there on the main page, you can check out some of the more recent videos and kind of really useful information for yourself to protect you, your family, your children from the threats from the online bad guys. So check it out. Let's continue on in our conversation here with Chris Harrison from Carnegie Mellon. Now, Chris, we were talking in the last segment about next generation touch. We didn't get a chance to really wrap up that part of the conversation. So share a little bit more about some of your other work. You talked about electric, but what are some of the other interesting projects you've got going on in this whole area of next generation touch?
Well, there's too many to really share at any given time, so I would encourage people to check out my website at the end of the show. But one project that I think is particularly exciting is this project that we've been working on for probably about 4 or 5 years now, and it's been miniaturizing some of the technology that I worked on even longer ago than that, which is to have interfaces that are both projected and can sense touches from afar. So whereas electric was a coating that you'd have to add on to materials, this is something that could be, on your ceiling and yet provide you a touchscreen-like experience on any surface in your house or office. And the way we've decided to wrap this functionality up, is as a light bulb. So right now we have in our prototype, in our lab, a standard screw fixture light bulb that when you screw it in, not only light comes out of it, but actually projected light that's structured. So you can see, for example, your Google Mail, calendar, tweets, whatever you want, on the surface of your table. So this might be something that you screw into the desk lamp above your table at your work, or maybe the recessed cans in your kitchen so that you can have projected information on the countertop. And what's interesting is that the applications have no idea that they're running on a wall or table or kitchen countertop. They think they're running on an iPad or an Android tablet. We sort of lie to the applications and we take care of all the projected graphical manipulations and also all the touch sensing, so they don't really know what's happening, and yet you can have this interactive experience live on your world. You don't have to put an iPad on your coffee table. Your coffee table can be a computer.
This is interesting because there was some work that I was involved in. We were doing very large displays for like advertising and end caps in grocery stores, those kinds of things. But one of the things that we always wanted was interactivity. And trying to do interactivity embedded in, glass, like on TVs or whatever, is really problematic. One, very costly, very expensive. But two, it requires a proximity that may be unnatural, right? So how do I interact here, which is much more natural of a tabletop than vertical, in your face kind of a thing. So you say you've got the prototype up. How big of a display surface does it simulate? Is it like a Is it simply an iPad Pro scaled up, or how big of a surface area does it really effectively become?
Yeah, it depends on how far away, obviously, the bulb is from the surface.
Right.
So we're using a scanned laser microprojector, so it's always in focus. So it doesn't matter if you're 2 inches away or 20 feet away. You'll always get these nice, crisp images. Obviously, the big downside with projectors as they stand right now is the further away you get, potentially the less bright they become. Although we can control the window of the expansion of the kind of the frustum of the projector, so we can always keep it sort of bright and tight. And these laser projectors, the newest prototype that we just got in the lab, is incredibly impressive, even in the middle of daylight on your desk. But generally, the surfaces we've been able to make augmented, the biggest one we have in the lab is about 60 inches across. And even though that's way bigger than an iPad, we don't tell the applications, oh, here's a 60-inch iPad. We tell them, oh, here's a little iPad for you here, and here's an iPad for you there. And they think they're running on an iPad, so they don't have to rewrite all the software.
Right.
But really, we can simulate like 20 iPads all over your desk, so that the apps don't have to be rewritten. They just work natively on whatever surface you want. But we would say if you're going to do something like a kitchen countertop, which might be 10 or 15 feet across, you might have to buy 2 or 3 of these what we're calling info bulbs. They don't just light, they actually emit information. And then they would actually kind of work with one another to provide a continuous experience across that entire surface.
So what's the commercialization path? I mean, this is the question I get all the time in my role, because I'm at a research lab. We don't build product, right? So we always thinking about commercialization. What's the commercialization path for InfoBulb or any of your other technologies at Carnegie Mellon?
Well, we have a really great tech transfer office, and there's actually a bunch of things that have been licensed out of the university. I also have started a startup company on the side to commercialize a lot of these touch technologies. So there's actually a couple different avenues that are in progress right now. For InfoBulb specifically, it's a research project because we're able to sort of probe at this possible future to discover where the pitfalls and where the benefits may be, which is sort of much less palatable for a lot of corporate research labs. And so right now, our very first InfoBulb prototype, which was more like the size of a shoebox, it was definitely not a light bulb-like form factor, and it cost something like $5,000, $10,000. So this isn't something that anyone's going to run out to Home Depot and buy a 10-pack of.
Chris, you're busting my bubble here. I'm in the middle of designing a new house, so you're telling me I can't get one?
Unfortunately not, but we're working very hard towards that vision, and I think easily within the next 3 to 4 years, you'll be able to buy this for less than the cost of a mid-range smartphone. And again, they'll just screw right into a standard fixture, and then you'll either speak a voice command or make a gesture, and then boom, your whole wall, refrigerator, door, whatever it may be, will be an interface.
That's amazing. I mean, it solves the problem of really what's the concept of device. The device versus the surface that you interact with. It totally disconnects them.
Yeah, we want to think about, right now we have an app store for smartphones and tablets. We want to think about what's the app store for your world. Imagine that every surface in your home was capable of simple but projected graphics and touch interaction. Every wall, every table, every furniture, whatever it may be. What kind of apps would you want to download onto your world? And you start thinking about a computer experience, not as a box that sits under a desk and a little rectangle that you stare at, but every surface can be draped with interactivity and information to augment your life. So you can walk up to the wall and turn on the light switch because one just magically appears in front of you. These are the sort of things that we want to tease at, and that's why it's still very much a research project.
Amazing. So you've got, I went out to your site, which is chrisharrison.net. And you've got links to all of your research projects, including desktopography, SkinTrack, OmniTrack, SkinPut, which is a lot of the work of projected interfaces onto skin, which I've seen a bunch of articles on that one, and I always think it's an interesting space. But if people want to track and keep up with what you're doing, what's the best way for them to find you?
I would say foremost, my website is the place to go because every research project is posted there. And we provide not only the papers for free, but also you can check out the video. And almost every project we do has a video because it's so visual. You need to see it to sort of believe it.
Right.
Although for kind of more up-to-date, more recent things, I would highly recommend just following me on Twitter. HCIProf is my handle.
Okay. And we'll have all of the links to track Chris down and keep up with what he's working on over at Carnegie Mellon, and If you had to pick one of these projects on a timeline, what do you think is the first one you think will get commercialized?
Well, there's already things that are out that are commercialized in the lab already. We have a technology called FingerSense, which is a touchscreen technology, software only, that lets the device disambiguate between a finger touch and a touch with your knuckle, which may seem kind of simplistic, but it basically gives you a right click on your finger, sort of like a 2-button mouse. And that's already running in something like 70 million devices.
Oh, wow. Amazing. That's great. Hey, Chris, I thank you for taking the time out of your Sunday to come spend time with us, with our guests. Thanks a lot. I wish you the best of luck, and we'll have to stay in touch and maybe have you back on the show and give us an update on your research. So,
yeah, sounds good.
When we come back, we're going to give you some more updates on what's going on here at the show, and be able to give you some insight and some exciting news. So don't go anywhere. We're going to be right back. And right after this quick commercial break from our sponsors, don't go anywhere. You're listening to Killer Innovations on the BizTalk Radio Network.
BizTalk Radio. This is Killer Innovations, a show about ideas, creativity, and how you can innovate. Welcome to the Innovator's Garage, where you learn to create your next game-changing killer innovation.
Welcome back to Killer Innovations as we come into the wrap-up segment of the show. We had just had Chris Harrison on, who is an assistant professor in, going to get this right again, human-computer interaction at Carnegie Mellon. And what Chris shared with us was some of his work that really caught my eye around this thing called electric. It's a spray paint that you can spray on surfaces and turn anything into a touch surface. And my particular interest was in supporting prototyping, the ability to create 3D objects and make them appear functional by making them have an electronic surface that then software allows you to define that this area of a surface means X, this surface means Y, and to do certain interactions. Why is this such a hot button, and why did I dedicate an entire show to this? It's because rapid prototyping is everything in the innovation game, and I mean everything. You know, it used to be we could take weeks, months, 6 months to do prototypes. In today's rapid change, you need to be able to do these prototypes in days, not months. I mean, literally days, right? Come up with an idea on Monday, work out the 3D model on Tuesday, 3D print it on Wednesday, prepare the surface on Thursday, and use some rapid prototyping and be able to demonstrate the basic functionalities on Friday, go off, test it, experiment with it. Monday, start the process again on the next idea. Historically in the innovation game, you would basically come up with a rough idea. You might do some crude simulations, or you would simulate the interaction through a series of storyboards or PowerPoints or whatever. And literally, you could take months in order to prepare this. I am a big believer in rapid prototyping, and I mean rapid with a whole different level. Rapid with a big R. And that is literally prototypes in days, maybe even down into hours. Can you cycle it through in 48 hours, 72 hours, and go through the entire cycle? Test, fail, test, fail, test, fail. Historically, though, the way this has always been done, at least in the high-tech industry, and I'm just talking about the high-tech industry here right now, is that you go off and you contract with an outside firm if you're not a hardware company to get some of the basic concepts done. You may go to an ODM, an outsourced design and manufacturing firm. So ODMs typically are based in Taiwan. They're scattered all over the world, but the highest concentration for them is in Taiwan. And ODMs will take your basic concepts and then work it through and actually build you the prototypes. You refine it. And then when you're ready to go to manufacturing, you hit the button and it goes into building final tooling and everything from the manufacturing. The problem with ODMs is that you can take a year to go through that entire process. And a year is a long, long time in today's highly competitive market that just has this insatiable hunger for new, creative, groundbreaking, game-changing innovations. So how do you do this faster? And that is, you got to bring that prototyping closer to you. And what Chris is working on, and there's other researchers out there working on, is this ability to allow for this cycle to happen much, much quicker. And that includes, what's the role of 3D printing? 3D printing allows you to get the physical object. You can test it in your hands, test it in your customer's hands, those kinds of, but they're non-functional. Chris's work brings it and turns it into functional. Some of the ODMs that I've worked with that are actually great companies and they're trying to step up their game in this space includes companies like Foxconn. Foxconn is the leading ODM from a standpoint of size in Taiwan. They are also the manufacturer behind the iPhone, etc. The other is Accentus. A lot of you don't recognize that name, but if you're in the high-tech world, which you may not be aware is particularly a lot of the software, if not the hardware, behind a lot of the technologies that you use every day is actually done by Accentus. And another is Flextronics. Flextronics actually is optimized to help in that prototype phase. They do everything from that early design work all the way through the prototype, through manufacturing, and extends into distribution. So a one-stop shop for entrepreneurs who want to take their ideas and take that forward. If you're interested in talking to any of those ODMs, I will have links up in the show notes over at killerinnovations.com. So you can check it out. You can link out to them and reach out to them. Tell them where you heard it. Let them know I referred you to them. And hopefully maybe they can take and help you take that idea that you've got and take that forward. And with that, I do want to reinforce a number of you over the years have always reached out to me to look for advice and guidance and send me, rough drawings or prototypes of the programs, that you are working on from the standpoint of products that you want to deliver. And I just don't, 2 arms, 2 legs, 24 hours a day. I don't have the bandwidth, and I want to help each and every one of you. So what we've done is, rather than this coming in sporadically from emails, is we've set up what we call the community. It's called the Innovators Community. It's a community. It's a Slack community. You can join it. You can participate. It's got leading innovators, startup entrepreneurs, young innovators, some of them still in college, to us old gray-haired people that have been around for a long time and have the scars of going through the pain and challenges of trying to take ideas and bring them to market. So check it out. It is theinnovators.community. I'll have a link in the show notes, but it's theinnovators.community. Or you can just search for the Innovators Community in Google, and it should direct you to the page. Then you can apply and join to be part of the Innovators Community. It is a Slack community, so there is a charge related to it because the cost of maintaining Slack and all of that, and we have some admins that keep it all up. But through the Slack community, we're also hosting private webinars just for those people in the community, and we also do face-to-face. So I've got one coming up in New York. Third week in New York, I will be in New York City, and we'll be hosting an event there to get everybody together there. So check it out, the Innovators Community. And so with that, I thank you. Check out the show notes, killerinnovations.com. Let us know what you think. If you have any show topics, let us know. Otherwise, we are going to sign off. We will see you next week. We will be live here in the studio, so check us out. Have a good week. Don't let the innovation outbodies get you down.
The opinions you hear on Biz Talk Radio are those of the hosts, callers, and guests, and do not necessarily reflect those of this station, Biz Talk Radio, its management, or advertisers. The information on Biz Talk Radio does not constitute a recommendation, offer, or solicitation to buy or sell any product or service. If you have any questions about Biz Talk Radio, contact us at 817-274-1609 or at biztalkradio.com. Biz Talk Radio.